Assalamualaikum. Today we are going to present a real-world problem of Fibonacci search method. Fibonacci search method, it is when we use ratio P that is built for the Fibonacci series and the value of P will change at each iteration. Fibonacci sequence are involved in this method. To get the sequence, we start from F1. We'll add with 1 and we get F2, that is the value of 2. To get F2 we'll add with F1 and get the value of F3, and the sequence will continue.
Our problem statement is we want to investigate how fast rabbit could breed. We take newly born rabbit, one male and one female, that we put in the field. Rabbit can mate after 1 month. At second month, the rabbit will born another pair. How we want to find total of rabbit, pair of rabbit in 1 year. For 1 month, we already have 1 pair. At the end of second month, the new pair is being born. At the end of third month, another new pair is being born that make 3 all pair together. At the end of fourth month, the original female will give birth to another pair, while the female from the second month will also be giving birth to another pair. That make all together 5 pair.
Now, imagine that there are k n pair of rabbit in n months. The number of pair in months n plus 1 will be kn plus the number of new pair born. But new pair are only born to pair at least 1 month old. In this case, we assume the rabbit never died. So, we will have the formula of k plus 1, which is simply the rule for generating the Fibonacci number.
To minimize this problem, we need to do several steps. First step, initialize point A, B, and the function. A and B is the duration of experiment. Step 2, find Fk. F is the Fibonacci sequence with K is equal to 1, 2, 3, and so on. N is the value of the Fibonacci sequence. Step 3, as chosen, interval A to B, we take K equal to 0.
So, for the fourth step, what we have to do is we need to find the interval A and B. So, how to find it? Okay guys, as you can see, this is a formula which is on how we can get the interval A and B. As we can see from the formula, which is AK plus 1, which is equal to AK plus rho K plus 1, returns to the interval B minus A. And it also same goes with the B, but the only difference is the rho we need to subtract with 1. I mean, we need to subtract 1 minus rho. Step 5, what we have to do is we need to put the new interval that we just find from the step 4, and then we enter it to the function. That's it.
The next step, which is step 6, what we have to do is we have to compare between the function A and the function B. So, let's say if the function A is greater than the function B, then the minimizer is like between the AK plus 1 and a BK. And if the function A is smaller than the function B, then the minimizer is like at the AK and BK plus 1. So, let's go to the next
Step
step.
7, B minus A from the reduced interval must be less than or equal to find the range. We should stop the iteration or otherwise go to step 4 for the next iteration. So, in conclusion, throughout the step above, the
the minimum point of minimizer will be the element of the interval AB for k from 1 until n.
For first iteration, we start with 1 minus rho 1 equals to f4 divided by f5, and we got 5 over 8. For rho 1 equals to 3 over 8. Then we compute the value of rho into the formula A1 and B1, and we got for A1 equals to 2.25 and for B1 is 3.75. So after that we substitute the value of A1 and B1 into the function, and we got for FA1 equals to 29.0625, and for FB1 equals to 28.4625. Since FA1 is more than FB1, the range is reduced to A1 and B naught equals to 2.25 and 6.
So for the iteration 2, we have 1 minus rho 2, which is equal to 3 over 5. So we have A2 is equal to 3.75, and B2 we have 4.5. So after that, we substitute the value of interval A2 and B2 into the function, and then we get for the interval A2 we get 28.4625, and for function B2 we get 32.25. So as we can see, the function of B2 is larger than the function of A2. You can see here B2 is larger than A2, so we can conclude that the range is reduced to A1 B2, which is 2.25 and 4.5.
In the next iteration, 1 minus rho 3 equals to f2 over f3 equals to 2 over 3. We get the value of A3 equals to 3 and the value of B3 equals to 3.75. When we substitute the value of A3 and B3 to the function, we get FA3 equals to 27 and FB3 equals to 32.25. We can see that the value of FA3 less than FB3. So we will reduce the range to A1 and B3, which is 2.25 and 3.75.
In the last iteration, we choose epsilon equal to 0.05. So we have 1 minus rho 4 equal to f1 over f2 equal to 1 over 2. The value of a4 is equal to 3 and the value of b4 is equal to 2.975. Then we substitute the value of a4 and b4 into the function. Fa4 equal to 27.0019 and the fb4 is equal to 27. We can see that fa4 more than to fb4, the range is reduced to a4b3 equal to 3.25. Note that B3 minus A4 is equal to 0.25, that's less than to 0.9. The value that minimizes the function is located in the interval A4, B3.